In this worked example, we're going to calculate a probability amplitude, which we're going to represent by these symbols here, this angle bracket plus 45 L. And we're going to use two different techniques using Dirac notation, this bras and kets, and also rows and column vectors. Now, what do we mean by all this? This is this notation that's introduced in chapter 3 in Beck to represent the polarization states of photons. And L is going to stand for the polarization state of a left circularly polarized photon. And plus 45 is going to correspond to the polarization state of a linearly polarized photon whose direction of polarization makes an angle of 45 degrees above the horizontal direction. And when we talk about calculating an inner product like this, we refer to it as a probability amplitude, and that's the probability amplitude that's going to be relevant. For example, if we try to answer the question, you send left circularly polarized light, a polarizer analyzer that makes a measurement to see if the photon is polarized along the plus 45 degree direction or the minus 45 degree direction. This quantity that we're going to calculate is going to be the probability amplitude for finding the photon polarized along the plus 45 degree direction. So for starters, I am going to do this calculation using what we're going to refer to as the bras and kets method. And I'm going to choose to do my calculation using basis vectors that are the H and V basis states. So with that choice of basis, I can represent a left circularly polarized photon as a linear combination of H and V, and this is the correct expression for that linear combination. And similarly, I can represent the plus 45 degree polarized photon as cosine 45 degrees times the H state plus sine 45 degrees times the V state, and that is, of course, just equal to 1 over the square root of 2 times H plus V, like so. And now when we want to write this is the ket, when we want to write the bra, it's actually pretty straightforward in this case because there are no complex quantities, so I can just write the bra associated with the plus 45 degrees state as 1 over the square root of 2 times the sum of the H bra and the V bra, like so. So now to calculate this inner product, plus 45 inner product with L, I'm just going to plug in. Okay, so I'm just going to copy this guy here, like that for the plus 45, and I'm going to copy like that. Okay, and now I'm just going to sort of multiply out. I've got factors of two factors of 1 over the square root of 2. So that's going to give me my inner product here that I'm trying to calculate is going to have a factor of a half out in front. And now these inner products I can treat, they obey the sort of rules of multiplication. So I can write this as there's a factor of H inner product with H and a factor of plus I times inner product of H with V. That's, these first two terms is this times this and this times this. And then there are two more terms. There's a product of V with H That's this times this. And then finally, a product of plus I V inner product with V, close parentheses. And now the H and V's form an orthonormal set. So the inner product of H with H is just going to be 1, and the inner product of H with V is going to be 0. Okay, so what we're left with is that the inner product of plus 45 with L is equal to 1/2 times 1 plus I. So I've calculated the probability amplitude using the Braz and Ketz method. And as a check, let's make sure we get the same answer using the quote row and column vectors method. Okay, so in this method, I am going to write the state plus 45 as a column vector, and the column vector there is going to be 1 over the square root of 2 times 1, 1. And similarly, I'm going to write the left circularly polarized state as a column vector 1 over the square root of 2, 1, I. So when I go to calculate the inner product plus 45L, the way we're going to do that is the plus 45 on the left-hand side, I'm going to represent as a row vector, 1 over the square root of 2, 1, 1. And then I'm going to multiply it by the L, which again is 1 over the square root of 2 times 1I. And now I'm just going to use the ordinary rules of the way you multiply matrices, basically. It's, the rule is it's I'm going to multiply the first times the first plus the second times the second. So what do we get when we do that? We get that this probability amplitude plus 45L is equal to, and I've got two factors of 1 over the square root of 2, so I'm going to multiply those out and pull it out in front. So I have a factor of 1/2 out in front, and then the result is just equal to 1 times 1 plus 1 times I, and that's equal to 1/2 times 1 plus I, which of course is the same result we got using the Bra and Ket method. So what's the physical meaning of this probability amplitude? Well, maybe the most straightforward way to answer that is to ask a specific experimental question. So this is using the notation and language of Beck chapter 3. We imagine that we have a polarizer analyzer that can make measurements with respect to the plus or minus 45 degree directions. Beck calls that a PA sub 45. And what that means is you send photons in and you make a measurement with respect to the 45 degree direction, and the photon either comes out along the plus 45 degree channel or the minus 45 degree channel. And the question that we might pose experimentally is, suppose you send a left circularly polarized photon into such an analyzer, what's the probability that it's going to come out along the plus 45 degree channel, and what's the probability that it's going to come out across the minus 45 degree channel? And the rules of the quantum mechanics game are, the way we calculate that probability is to take the magnitude of the probability amplitude, the correct probability amplitude. We take the magnitude of that and square it to get the result. And remember, this probability amplitudes are in general complex numbers, so you have to remember how to take the magnitude of a complex number. And let's do that in this case. Well, our probability amplitude has a real part and an imaginary part, and the way you calculate the magnitude squared of a complex number is to take the magnitudes of the sum of the squares of the magnitudes of the two parts. So when we do that in this case, we get a 1/2 squared is 1/4, and the imaginary part is also 1/2. So when we square 1/2, we get a fourth. So it's a fourth plus a fourth equals 1/2. And what that means is that if we send our left circularly polarized photon into our polarizer analyzer that's making a measurement with respect to the 45-degree direction, half the time it's going to come out along plus 45, and that must mean that the other half of the time it comes out along the minus 45-degree direction, which I suppose is not a very surprising result in this case. So that's it for this worked example. Hope to see you again soon. Bye-bye.